Alright, Physics 2212 Lab 3, Introduction. So the purpose of this lab was to measure the distance dependence of the magnetic field due to a small bar magnet and compare measurements to the distance dependence predicted by the Biot-Savart law, that is experiment versus code. Concepts and principles used in this law is the Biot-Savart law, off-axis magnetic dipole, you'll see that later on in the code, and the magnitude of the magnetic field of the bar magnet. We have the distance dependence formula right here. This was given in the lab sheet. We have superposition, b net is equal to b1 plus b2, and we have linearization with using the logarithm function. That was also given in the lab sheet. We use that in the Excel sheet. Main results, we have the calculated mu mag to be 0.979, n to be negative 5.1516, and k to be 3.23 times 10 to the negative 9. Moving on, we have our system, which was a bar magnet, and surrounding was everything else. Assumptions we made in this lab was that no other magnetic field is accounted for, only the bar magnet and Earth. We assumed the bar magnet was represented perfectly as a dipole, magnetic dipole, and we assumed that the magnetometer chip was set up correctly. Sorry, I'm going to be messing that up. Alright, so to start off our experiment, we compensated for Earth's north pole. We rotated the phone until the x component was 0. Then we found the magnetometer chip in the phone, which you can see throughout the diagrams. Slid the phone up while holding the magnet at a fixed position. Looked for greatest x value, rotated it, and repeated the procedure. And then after we found the magnetometer chip, we measured by sliding the phone along the x-axis until the magnetic field was equal to the value we were looking for, and we recorded the distance. For our off-axis portion, we found a distance d perp where the magnitude of the magnetic field was 100 microteslas. We recorded the y value, then slid it up another distance d perp, and recorded the xyz values at this distance. Then we found Earth's magnetic field, the y component, from an online site. Observations we made in this lab, I'm going to go over the true ones. When the magnetometer is far away from the magnet, it measures the near zero magnetic field in the x direction. We found that to be true. And as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. We found that to be true as well. For our Excel sheet, you can see our on-axis measurements right here. We were looking for these bx values, and when we found them, we recorded the distance. We used the average of those to plot this graph. And for our off-axis, we have our d perp right here. Do the experiment, and we fill in the xyz, and we have our magnitude of the b net as well as the average of the components below. Calculations we can make from that Excel sheet, we found n and k, and we went over their values earlier. Using this magnitude of the b bar formula and equating it to the distance dependence formula, we can find r and mu mag. R is 0.1484 and mu mag is 0.979. Now, going over the code, we can go through that right here. First, we inputted our mu mag value right there, defined a function using the dipole B formula we went over in the beginning, had a scalar for arrows, some arbitrary distance for our parallel and perpendicular arrows. We have our d perp right here that we found, and then we use that d perp and the function we defined to make a vector for the magnetic field at a 45-degree angle, which you can see right here, along with our parallel and perpendicular arrows. Now moving on to the slide. Comparison. So our experiment values from the Excel sheet are right here, and our code values that we just went over are right here. And as you can see, they differ by quite a lot, and let's get into why that is. So for our sources of error, we can recall the assumptions we made, how we assumed that no other magnetic fields were accounted for and that the phone was set up correctly. The magnetometer in our chip in our phone may not be accurate. It varies depending on model. And the magnetic field of the Earth might have been taken from an incorrect source, or the source might have had it wrong. And other equipment such metal could have been messing up our measurement. We tried stacking foam underneath our phone, but there might have still been too much interference. What if and why? Well, just two what ifs for this lab. What if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? So the values for B perp would be drastically different. The values for the x and y components would be a combination of the field from the bar magnet and the Earth, assuming no other fields are in play. What if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? The magnitude of the magnetic field would be greater, however the direction would stay the same. And that's the end of our slide. Thank you.